In this episode, we will model the functions mapping harm and intention and wrongness for human and machine actions. To keep things simple, we will use some very rough assumptions. Even though wrongness, harm, and intention change depending on whether the scenario was an action of a human or a machine, we will use these variables together in a model. This model will estimate the level of perceived wrongness of a scenario as a function of that scenario's level of perceived intention and harm. Because the dependent and independent variables are affected by the treatment, whether the action was that of a human or a machine, this would be what in statistics is known as a heroic assumption, an assumption that even those using it consider untrue. We find our model captures some qualitatively interesting patterns, namely that differences in people's judgment of humans and machine actions are not simple preferences for humans over machines, but involve differences in functional forms. We use individual-level data, including more than 27,000 individual responses. Our goal is to estimate the following two functions to predict the wrongness of the actions performed by humans and machines. A function that equates the wrongness of an action for a human as a function of intention and harm, and the same function for a machine. Using a Taylor expansion of the previous two equations, we get the following model for the wrongness of a scenario W as a function of H, harm, and I, the level of intention. We also have fixed effects and, of course, a residual. Our model includes individual fixed effects to capture any source of constant variation between individuals. This is a collection of vectors that are 1 for each individual and 0 for everyone else. These vectors can capture any constant source of variation among experimental subjects, such as differences in age, gender, languages spoken, race, or even shoe size. Fixed effects can also help us control for behavioral characteristics, such as some subjects being too judgy and judging all scenarios too harshly. After fitting the model to the data, we can explore the differences between the functions describing people's reactions to the actions of humans and machines. We find that intention enhances the perceived wrongness of human actions more than that of machines. This comes from the dominance of the interaction term between harm and intention in people's reactions of machine actions. People's judgment of machines is dominated by the slope of wrongness on harm, suggesting that humans are judged by their intention, while machines are judged by their outcomes. Of course, this is a simplification, but to a first approximation, these differences in the relative importance of coefficients describe coarsely and qualitatively the differences between these two moral functions. Also, we find that at high levels of harm and intention, human actions are judged more harshly. As a result of that, humans appear to judge the actions of other humans more harshly at the highest level of harm and intention, but they judge machines more harshly in the rest of this space. Certainly, this is a crude approximation, but it serves as a quick rule of thumb that we can use to guide our intuition about expected differences in people's reaction to human and machine actions. But are these judgments affected by the characteristics of the observers? Do people with different ethnicities, genders, or levels of education judge things differently? Are some of these groups more inclined to judge machines or humans more harshly? In the next section, we continue our statistical exploration by looking instead at how the demographic of experimental subjects correlates with their judgment of humans and machines.